Hi everyone, welcome back to my channel. Today we'll be discussing the new topic that is electrolysis. So before beginning with this new topic, please do hit the like button, share the video with your friends and subscribe my channel. Now we are going to cover the last chapter for the semester 1 syllabus for your board examination, which is electrolysis. So before starting off anything, you first need to know what is electrolysis. Electrolysis is composed of two words, that is electro and lysis. Okay, where the electro word means the flow of electrons or electricity, and lysis means the breakdown or separation of into ions. Breakdown. Okay, when when a compound is dipped into a solution in aqueous solution and electricity is passed through it, okay, that compound will break into its constituents, that is ions or molecules. That breaking is known as lysis, and as electricity is used, it is known as electrolysis. So how you will define electrolysis? It is a process of chemical decomposition of a compound in aqueous or molten state. Okay, why we will do in aqueous and molten state, I'll just explain later on. Okay, when a electricity is passed through it, which result in discharge of ion as neutral atom and respective electrodes, what will happen? Suppose you will have a compound NaCl. So when electricity is passed through it, it will break into its ion, that is Na plus Cl minus. Now each ion will go to a different place and get deposited there. Okay, that deposition will take place at the respective electrodes. Okay, and the process is called electrolysis. It is a redox reaction, that is, it is a two-step process where at one step you will have oxidation occurring and at other step you will have reduction occurring. Okay, as both reduction and oxidation occurs simultaneously, therefore electrolysis is a redox process. As well as it is a chemical process because a new compound will be, a new product will be formed on decomposition of the compound. Okay, now we will learn what is electrolyte. As we have discussed that certain compounds allows electricity to pass through it, when electricity is allowed to penetrate them, that kind of compounds are called electrolytes. Okay, they will conduct electricity in their aqueous or molten state, because in aqueous and molten state the ions are free to move about. Due to the free movability of the ions, they conduct electricity. But in solid state, what happens due to the tight packing of the molecules, they cannot move around freely. Hence, they do not conduct electricity in solid state. Okay. So, what kind of particles would be present in electrolyte? Either it could be composed of only ions or ions and molecules. Okay. There are certain examples of electrolyte, like just in our previous chapter we have read acid basis salt. So different acids, different bases and different salt can behave as electrolytes. Okay, all strong acids behave as an electrolyte, all strong bases behave as an electrolyte, and salts of strong acids and strong bases behave as a electrolyte. Clear? Now electrolyte can be further classified into two subdivisions, that is a strong electrolyte and weak electrolyte. So what are the strong electrolytes? Suppose I'm taking an example of in generic a compound HX, which is an electrolyte. Now, on passage of electricity, if it completely dissociates into its ion, okay, then they are termed as strong electrolyte. Okay, this solution only consists of ions. Strong electrolytes will only consist of ions because they easily break into its constituents, and they are a good conductor of electricity. Obviously, if they are breaking into ions, they will allow more electricity to pass through it, so they are good conductor of electricity. Okay, whereas what will be the weak electrolyte definition? You have a compound BX. It will also undergo dissociation, but to a lesser extent, or partial decomposition will take place. That means, suppose you have 100% compound, only 5% of it will undergo dissociation and rest will remain as it is. This kind of compounds are called weak electrolytes. Okay, so what kind of particles will be present in them? They will have ions, but they will have large percentage of molecules, that is undissociated ions will be present in excess. Clear? They are poor conductor of electricity because of the low formation of ions. Okay. Now, what are the examples of strong electrolyte and weak electrolyte? All strong acids like HCl, sulfuric acid, nitric acid are strong electrolyte. All strong bases NaOH and KOH are strong electrolytes. So, salts like NaCl, which is made up of NaOH and HCl, they are strong electrolyte. Lead chloride, lead bromide, lead chloride, copper chloride, copper sulfate. These are all strong electrolytes. But all your organic salts like carbonic acid, acetic acid, oxalic acid are weak electrolyte. Weak bases like calcium hydroxide and ammonium hydroxide are weak electrolyte. Simultaneously, the salts which are composed of any other weak acid or weak base, they will itself become weak electrolyte. Okay. Now we have read about electrolyte, but there are certain compounds which behave as non-electrolyte. What are they? That is, they neither in a solution, that is an aqueous state, or in molten state allows electricity to pass through it. Okay, that means they will not break into its ion. So they do not have any ions formed when they are dissolved in solution and allow when electricity is passed through it. They only consist of molecules. Okay. So we have read about electrolyte, two classes, weak and strong, and non-electrolyte. Okay. So what kind of particles are present in them? In weak, in strong you have only ions. This is ions plus molecules. But in case of non-electrolyte you have nothing, only molecules, no ions. Okay. So what are the examples? You need to study the examples of non-electrolyte because in your MCQ question you might be asked to choose which is a non-electrolyte. Okay. So distilled water, kerosene, carbon disulfide, benzene, glucose, urea, sugar, alcohols, oils. Okay, all are non-electrolytes. Clear? Now to conduct electrolysis, we need a vessel where we can carry out electrolysis. That is known as electrolytic cell or voltmeter. So what is its use? It will convert electrical energy because you are passing electricity into a chemical reaction so that a chemical reaction can occur. Okay, so it is composed of two electrodes, two ends which will consist of two electrodes. Examples of electrolytic cells are voltaic cell and Daniell cells. Okay, now what are electrodes? The two metal plates, see here, these two metal plates, this one and this one, which acts as a road through which the electricity can enter and leave the electrolyte is known as electrode. That means they will allow the passage of current to flow through it. They will act as two roads where from one road you will enter the current and from the other end the current will leave through the electrolyte. Okay. Now since you have two metal plates or two wires or two rods, they are termed as anode and cathode, where the anode is the positive end and the cathode is the negative end of the battery, a negative pole. Okay, so since it's positive and negative, you'll put the sign plus and minus. Now when the current is turned on, cathode becomes negative electrode, which electrons enters the electrode, and the anode becomes positive, by which the electron leaves the electrode. That means from your anode electrons will leave and all the electrons that has been liberated from the anode will go to the cathode. Clear? You need to learn about the difference between anode and cathode. Very important. Anode is the positive terminal of the battery, will be connected to the positive terminal of the battery, whereas cathode will be the negative terminal. Now as you all know that opposite attracts, that means at cathode you will have cations migrating. Clear? Because it's negative and cations are positive, so that will migrate towards the cathode. Similarly at anode, anions will migrate because anodes are positively charged. Now, as I've discussed, at anode electrons are leaving. As electrons are leaving, that means you are having a loss of electrons. So at anode, oxidation takes place. Okay, whereas at cathode, all electrons are getting dumped. That means you are accepting electron. So there is a gain of electrons. So reduction is occurring at cathode. Okay, clear? These three differences are very important for your anode and cathode. Okay, now you will need to learn what are ions. The ions are basically group of atoms which have some charges. You have read in your junior classes. Okay, where suppose an atom in a neutral state loses or gains electron, either it will lose electron to form an ion cation, or it will gain electron to form anion. So these species are called your ions. Cations will carry positive charge and anions will carry negative charge. Certain examples are given here. Okay, clear? Now you need to learn the difference between cations and anions. Very easy. Cations are positively charged and ions are negatively charged. Clear? As it is positively charged cations, they will move towards the cathode, and anions will move towards the anode because it is positively charged. So at cathode, they will gain electron and get reduced to form neutral atoms. Clear? Okay. Whereas at anode, they will lose electron because anode, their oxidation takes place, so they has to lose electrons, and as they'll get losing electron, they get oxidized to form neutral atoms. Okay, that is, anions will lose electron to form the neutral atom, and cathode cations positive charge will gain electron to form neutral atom. Clear? So till now we have discussed about the electrolysis definition, types of electrolytes, strong or weak or non, then your electrolytic cell where you will conduct electrolysis. So you need to learn about the characteristic of electrolysis. What are the characteristics? On passage of electricity through electrolytes, metallic ion move towards the cathode and non-metallic ion move towards anode. Okay. Now, suppose in your solution you will have different kinds of ions or will be formed. Okay, different kinds of positive charge species and different kinds of negative charge species will be formed. So there is a special preferential discharge of ions depending on the position of electrochemical series. That means which ion will be preferred over the other. It is determined on its position where it is placed in the electrochemical series that I will discuss in my next video. Now, the number of electron gained by anode must be electron gained by cathode, sorry, must be equal to the number of electron donated by anode. That is, if anode donates 2 electrons, the number of electron gained by cathode has to be same, and you will have products form as cathode and anode. Okay. Now I have continuously talked about the term dissociation. That means in electrolysis dissociation occurs, but not ionization. Dissociation means suppose the compound itself is present in its ionic form. That is, I'm saying, that is, suppose you have NaCl. Okay, NaCl, it's Na is itself in Na plus and Cl minus. You do not need to form ions. Here the ions are only combined to form the compound. Now, electrolytic dissociation means is a process where it will involve in just the separation of the ions. Ions are already present. You just need to provide electricity or heat to just separate the ions. But in case of ionization, the compound is present in its molecular form. So on supplying electricity or heat, what will happen? The molecule will get excited and it will form ions first. Okay, that is the difference between electrolytic dissociation and ionization. In ionization, you need to form ion. But in dissociation, ions are already formed, you just need to separate them. Clear? Now, what is the whole process of electrolytic dissociation in an ionic compound? Ionic compounds, as we have read in the chemical bonding chapter, are nothing but compounds which are composed of positively charged ions and negative charged ions which are not free to move about due to the strong electrostatic attraction between them. Okay. Therefore, in solid state, as they are strongly bound, they are not free to move. They will act as a bad conductor of electricity. Okay. But what will happen when you supply heat or electricity? They will gain kinetic energy and start to move freely as ions will start to break. So in molten solution, that is, you're changing the state of the matter of the compound, it becomes a good conductor of electricity because of the free movement of ions. Similarly, in aqueous state, water, and aqueous state, what you have as a solvent? Water. Water is a polar compound, okay, which itself, water has a structure like this, where delta positive charge over hydrogen and delta negative charge over oxygen. So what will happen? It itself is polar, that is, there is a charge separation between its combining atoms. So when a ionic compound is dissolved in water, what it will do? The negative portion of the water, that is oxygen, will pull the positive charge of the part of the ionic compound towards itself, and the negative part will go towards the delta plus of the hydrogen. So there you will see that due to the slight negative charge over the oxygen atom, it will pull the positive part of the ionic compound towards itself. Similarly, the counter negative part of the ionic compound will be pulled towards the hydrogen ion. So the ionic compound will dissociate into its ion and it will easily move about in solution freely and will conduct a good electricity. Okay, clear? Now, in covalent compound, you first need to do ionization. What will happen? Non-polar compounds are polar covalent compounds are non-electrolyte in gaseous state, but ionization in solution state. In gaseous state, they are not free to move about, so they will not conduct electricity. But in solution state, what will happen? Since water is a polar compound, just as I have explained earlier, the negative part of the water will pull the positive part of the your covalent compound towards itself, so that the ions will get separated and it will move freely and become a good conductor of electricity. So covalent compounds will become good conductor of electricity or as electrolyte only in an aqueous solution. Okay, now till now we have discussed about the conduction of electricity in electrolytes, but in metals also electricity passes. Okay, so we have read that metals are also good conductor of electricity. So what is the difference between metallic conductors and electrolytic conductors? In metallic conductors, the flow of current consists of only single stream of electrons from negative pole to the positive poles. Okay, but in a electrolytic conductor, the flow of current consists of two streams, one of positive cations and another of negative anions. Clear? Metallic conductors are good conductivity of electricity in solid state also, but electrolytic conductor will not conduct electricity in solid state, only in molten and aqueous state they will conduct electricity. No change of form or composition occurs during conduction of electricity, that is, it is a physical process, and in case of electrolytic it is the chemical process. Okay, new compounds will be formed. Also, in case of metallic conductor, it is only due to the movement of electrons which will conduct electricity, but in case of electrolytic conductor, it is due to movement of ions. Okay, which will conduct electricity. So today I will be stopping here. In my next video we will be discussing about which ions will get preferred over the other to get discharged as respective electrodes, and we'll discuss some few examples of electrolysis. Okay, we'll take up some few examples of the compounds to show electrolysis. Okay, thank you.